Naming by Shui and Carrie Rucker. The first kind of naming we will go over is for ionic compounds. Ionic compounds consist of a cation and an anion, typically a metal and a nonmetal. However, sometimes a positive polyatomic ion such as ammonium or dimercury can replace a metal, and a negative polyatomic ion such as chlorate or sulfate can replace a nonmetal. When these cations and anions come together, they form ionic compounds. Polyatomic ions are very important to be able to name compounds, so we would like to share a quick mnemonic with you now. The mnemonic is Nick the camel ate a chancy clam for supper in Phoenix. Note, this is only for the eights with oxygens. The important words to use in the sentence are Nick, camel, chancy, clam, supper, and Phoenix. In each of the words, the number of consonants represents the number of oxygens in the polyatomic ion, and the number of vowels represents the charge. The first letter also shows which polyatomic ion it is for. For example, let's start with Nick. This starts with N, so it is for nitrate. N is nitrogen. If we count the consonants, there are 3 of them, so we know that there are 3 oxygens. If we count the number of vowels, there's only 1, so we know that it has a charge of -1. Continue like this for the rest of the words, and the polyatomic ion equivalents are shown. Now you have less to memorize. In order to name ionic compounds, first you name the metal. Then you add I to the second word, unless it's polyatomic, in which case you don't add anything, you just leave it. Let's look at some examples. Our first example is KBr. K, potassium, is the metal, and Br, bromine, is the nonmetal. To name this, you start with the metal, so that would be potassium. Then you go to the nonmetal, and remember to change the ending to "ide", so you would have bromide. Thus, the name of KBr would be potassium bromide. Now let's look at an example with a polyatomic ion. Here we have LiClO3. The metal is lithium, and we have a polyatomic ion, which is ClO3. To name this, we would name the metal first, like before. So we would have lithium. Then we would name the polyatomic ion, but we don't change the ending. So we would have chlorate. Then when we put it together, we would have lithium chlorate. Let's try one with a transition metal. It's a little bit different because you have to put the charge of the transition metal in parentheses in Roman numerals. Here we have FeCl3. Fe, or iron, is a transition metal. We start the naming process the same way by naming the metal. However, we now have to figure out the charge of iron. To do this, we start with the charge of 1 chlorine ion, which is -1. Because there are 3 chlorine ions, we have to have a total charge of -3. To balance out the charge so the compound is neutral, the total charge of iron must be +3. Since there is only 1 iron atom, the charge on an individual iron atom is +3, so you would write 3 in parentheses using Roman numerals. Then you name chlorine as you normally would. Change the ending to "ide" so you have chloride. Then when you put it all together, it is iron 3 chloride.
Next, we will go over how to name covalent compounds.
Covalent bonds are formed between 2 nonmetals. However, sometimes a metalloid can take the place of one of the nonmetals.
Let's go over some rules for naming covalent compounds. First of all, always use prefixes. However, don't use mono if it's on the first word. Also, you should always change the ending of the second word to "ide". Here are the prefixes. As you can see, 1 is mono, 2 is di, 3 is tri, etc. These prefixes should be added on to the name of an element depending on how many atoms there are of that element in the molecule. Let's go over an example. Here we have P3N5. First, we would identify how many atoms of phosphorus there are, in this case 3. So we would write the prefix tri. Remember, if there were only 1 atom of the first element, you would not use a prefix. Next, we add phosphorus onto tri. Since there are 5 nitrogen atoms, we would start with the prefix penta. Next, we add the stem of nitrogen, but we have to remember to change the ending to "ide". This leaves us with triphosphorus pentanitride. We will now go over acids and bases. The first type of acids are binary acids, which consist of a hydrogen followed by another element, usually a halogen.
To name these binary acids, you use the formula hydroblankic acid. For instance, we have HF. This is a binary acid, so you would use the formula hydroblankic acid. Then you take the stem of the element that follows the hydrogen, in this case fluorine, and fill it into the blank. So therefore, we would have hydrofluoric acid.
The other type of acids are oxyacids, which are made up of hydrogen, oxygen, and one other element, usually a nonmetal. The oxygen and other element are effectively a polyatomic ion.
If the polyatomic ion has the per 8 formula, then you name it per blank ic acid. If the polyatomic ion ended in 8, then you would have blank ic acid. If the polyatomic ion ended in ite, then you would have blank us acid. And if the polyatomic ion has the hypoite formula, then you would have hypo blank is acid. For example, we have H2SO4. SO4 is sulfate, and because it ends in 8, we know that it will be in the form of ic acid. Then you plug in the stem for sulfur, which is sulfur, and we have sulfuric acid. Bases are basically just hydroxide ions with a metal, and you name these exactly like ionic compounds.
The last topic we will go over is how to name hydrates. Hydrates are compounds containing a definite ratio of water molecules as part of their structure. Let's go over an example of a hydrate. Here we have ZnCl2 4H2O. First, we would name ZnCl2 the way we went over in ionic compounds, which would give us zinc chloride. Next, we would identify the number of water molecules. In this example, we have 4. We use the same prefixes used in the covalent compound section, so we start with the prefix tetra. Next, we add on hydrate, leaving us with the name zinc chloride tetrahydrate.